guys, you're very welcome back to the channel. In the previous video, essentially what we did was we basically set up our surface creation logic to essentially create our Vulkan surface, right? So in today's video we are going to continue from there. Simply let me just mark this as complete. Use green here. So we basically did that. So what we now need to do essentially is the swap chain. So this is what we're going to be doing in today's video. Hopefully I can do everything in one video. So yeah, let's see how far we get. All right, so again, let's get back to our code base here. Now I already created two files for the swap chain. So we have the Vulkan Swapchain.h and then the Vulkan Swapchain.c as usual. And then I also believe I just included it in here somewhere here. So we included this in the Vulkan renderer.c. So make sure that you also include that in there. And then I just recompiled my project to make sure that everything was indeed working correctly. Based on the previous project, and it still does. So I'm just gonna split my terminal here again, just to restore my setup. I'm gonna cd into the bin on this side and then just clear, and then just run the app just for good measure and see if everything is still working, and it does. So I'm just gonna clear all of this up. All right, sweet. So now let's get started on the swap chain. Now for the swap chain, I think we might need some new struct definitions. Mainly because if you look at the tutorial here, I'm gonna skip these because we already handled these in the previous video. So everything that has to do like extension support, VK Swapchain extension names and all of that, we already set those up, and everything is basically ready for us to actually create the Swapchain support. So we can start following the tutorial from this point, whereby they define a struct called Swapchain support details. So this is what I am going to define right now. So I'm just gonna copy this. Yes, there is some C++ in there, but I'm just gonna strip the C++ stuff out. So I'm gonna paste this right here. And then I'm gonna rename this. So I'm just gonna make everything lowercase letter. So that will be Swapchain support. Actually, no. This has to be capital letter based on my own naming naming convention, I guess. Yeah. So let's do it like that. So that's Swapchain support details. I'm gonna save this. So then we have the capabilities. I'm not gonna change that. Then we have the VK surface formats. So the only thing I need to do is just get rid of the vector. So I'm gonna multi-select here, get rid of that, get rid of this and that. And because these are arrays, what I'm gonna do is I'm gonna put pointers here to point to the array that we're gonna create for these two. And then present mode, I guess I can split this up like this and so, and that is perfect. So then we have, just in case this is not clear, this will be an array, and this will be an array. Now I could have indicated this by using a double pointer like this, but I don't want to, based on the way that I do things. So yeah, this is the way I'm gonna do it. I just know that it's an array because it has a plural at the end. So that's it. All right. Then I guess after we have this, we need a function to query for the Swapchain support. Okay, then we're gonna need a function to basically get the surface capabilities. Okay. All right. And then we need to choose the Swapchain format. I think I'm gonna start with these functions. And then they choose the present mode and the Swapchain mode because they're fairly small. So I guess we'll just start with those. Yeah, so I'm going to create a function that will create the swap chain, and then inside that we do this. Yeah, I guess we can follow along with the whole Vulkan tutorial situation. So let's go back up here and see what exactly it is that we truly need. So we've set up the struct here. Next we need to query for the swap chain support. Let me see. Okay, let's go to our header file, and then in our header file, let's figure out what is the API here. So I think what I can do is just create two functions. One will be to create the swap chain, and then the other one will be to essentially destroy the swap chain. Right, so let's do that. So let's do a boolean, and then let's do hold on, Vulkan, if I can just spell Vulkan create a swap chain. Okay, this will create a swap chain, and let's just include our defines here. So let's do Vulkan defines.h, and then after that we can basically make use of the Vulkan context, which will have the data that we need to make use of. Okay, then I'm just gonna copy this, and instead of create, it will be destroy. So we'll create the swap chain and then destroy the swap chain, and the signatures should just match one another. I think for destroy we can just make this a void, so that it doesn't have to return anything, and then we can just copy these and paste them in the implementation file, and then just open this bad boy and open this one, and for now we'll just return true, just so that we can get rid of the error and the warnings, and here as well. Okay, oh yeah, I forgot that this doesn't return anything, so it's fine. And that's it. So let's see what we need to do. Keep going to the wrong side. We need to query swapchain support. Do I want to query for swapchain support? I guess. So let's create a function to do that. Yeah, so let's create one and just make it static, right? So let's do static boolean, and call this query swapchain support, like this, and then just pass in the Vulkan context. Well, I guess I have to type that on out context like so, and then just save, and then by default again we will just return true. So return true, like so. Lovely. So let's implement this. So again, wrong side. Swapchain support details, get physical device okay, well, basic surface capabilities. I guess I might need this, so let's just copy this. Yeah, let's copy that, paste it in here, and then I'm going to need to pass in the VK device, I presume. So let's see, physical device, so we need the physical device, so that will be context slash physical device.gpu, and then it wants the surface, so that is actually in context slash surface. Okay, then it wants the capabilities to store to. So let's see, context, and in fact I guess we might have to add some modification to our context situation here. So we want this, right? But I think it'll be safe if we create a struct here called swapchain. So let's do struct swapchain, and then will this conflict with the Vulkan swapchain? I don't know. Let's just do it like this for now, I guess. And then in here we'll have the swapchain details. So let's just do details. Yeah, let's just do it step by step, right? So this should be, actually this should be a type def struct, this one as well. So I'm sorry about that, guys. Type def struct, like so. Yep, sweet. Then in the Vulkan physical device, do I want it in the physical device or do I want it in the context itself? Interesting. Well, let's put it here first and see if that does anything, and then if we need it to be here or not. I'm not quite sure where I want it, but yeah. So this will be the API for us, right? So now I can go back in here, and then we can say context.swapchain.details.capabilities, and then we just get the reference to that. Okay, and I should just query for the capabilities, and then I believe the next step is to get the format. So let's do that. Okay, so let's go ahead and do, I guess we can just comment here and be like formats. Then we can do a U32. Then I can say format count goes to 0. And how are we querying for these? How do we query for this? I guess we can just copy this, paste it in here. And then, do they want the physical device? Yes. They want the surface, and they want the format count. So this will be this. So let's just paste this here, and then the null pointer will be 0 for now because we just want the number of formats, and then device and the surface will be these guys here. So I can just copy this and replace this with that. Beautiful. And that's about it. And actually, let's test this. So let's do, I'm gonna need my let me see, debug. Yeah, I'm gonna need my core logger. So let's do core/logger. Then I can do debug/formats count. I just want to see how many there are, and that will be a decimal number, and that should be format count like this. And then in the Vulkan create swapchain, I'm just gonna do query support, and then I'm gonna pass in the context like this, and then it means I'm gonna have to call this function in the renderer, Vulkan renderer, right here. I guess we can do if swapchain, swap. Interesting. It's giving me the swapchain. Didn't I include the swapchain headers? Maybe I need to save. Oh, it's called Vulkan create swapchain. My bad. So back in the renderer, we just say Vulkan create swapchain, then we just pass in the context, and then if it fails, we just do fatal. Let's do failed to create Vulkan swapchain like this, and then we just return false here, and that's that. And now that we call this, it'll call this guy. So let's test that. And then it bolt. So let's open the app, and it works. And here it says formats count is 60. So we have 60 formats. That's a big number, but at least we know it works, right? So I can basically get rid of this. We know that it's 60. So we're gonna need to basically search for the formats that we want to support, right? So let's see how they're doing that. So they're checking if it's not equals to 0, and then they're gonna resize the array. Ooh, we will have to set our array as well, and then get the surface, and then basically store that in the array, the formats, and then store that in the array. So I guess we can copy this, paste it here. Just save this, and instead of checking if it's not equals to 0, let's just say if it's greater than 0, right? Okay, yeah, so if it's greater than 0, then we have formats. So let's do, wait, what was this? Details, formats, resize. So they're resizing the array. So for us, instead of resizing, we need to create the array. So let's do context /swapchain dot detail. Well, where is this actually? Where is the formats again? Oh yeah, it is in the detail, so I was correct. So back in here, let's do swapchain.details.formats. That's our array, and we need to allocate the array. So let's do array. In fact, now I'm gonna have to include my array container. So let's do include container / array.h. So array create. Let's do swapchain image formats. What is the type here? This is a VK surface format. Wait, no. Let me just go back here. Oh, it is. So it's fine. Let's go back and paste this in here. Right, and then instead of actually creating, because this will just create the array with the size of 1 and then dynamically resize. So what I want to do is, instead of having to resize this later on, let's just create enough space for the amount of formats we actually support or have support for. So in this case, it's 60, but we need to basically properly get that using the array, the variable that stores that value, in this case format count, and then this should create the array for us with space for 60 formats. Okay, and currently right now it's empty, so we need to populate it, and we populate it using this function here. So it wants the device, it's the physical device, the surface, and the format count, which again we already have this information up here. So I'm just gonna copy this and replace all of this with that, and I guess it would be safe for me to try and move this to a new line, just so that you guys can see what I'm seeing. And then the format count, okay, it's fine. Then I need a comma here. Then this should be the array we storing this in, and that array is simply this. So we can copy that and replace this with that. Okay, and we can just take the address. Well, I guess we don't need the address because it is a pointer at the end of the day. So that is our context swapchain details formats. Okay, so it will get stored in that array, and then after that, what do we need to do? Get the present modes. But before that, because we're using our own custom container, we need to update the count, because Vulkan directly modifies this array block of memory, right? But it doesn't update it to say, hey, yes indeed I just put 60 elements in there. We need to do that explicitly, so we can do that by saying array set count, just to ensure that indeed it is 60. So it's just a safety check for us. So what array are we modifying? This one right here. So let's pass that in and then make sure that it is indeed 60. So you do that by simply passing that in there like that. Okay, so now what we need to do is also get the present mode count and query for those. How do I want to do that? Query support. I guess we can do this outside of this, and then we can just put a comment here just to know what we're doing. So present modes. Okay, and then for present modes we can do basically the same structure here. So I'm going to copy this whole thing, and then paste this, and then instead of format count, this will be present mode count, or I guess modes count. Let's just do present mode count like this, and then instead of VK device surface formats, I think it's present modes. So let's just fix that, and then it takes in the device, the surface, and the present mode count. So we just need to take this count and update the format count with that, like so, and like so. And then instead of formats here, it should then be, let's see, present modes, like so. And then instead of VK format KHR, the formats, let's just see what it is. It's present mode KHR. Okay, so here we're passing present mode KHR, right? Yeah, that's what we should do, right? So I'm gonna save this and then see what I need to modify. This is correct. Format count needs to go, needs to be present mode count, and then this needs to change and this needs to change, and then instead of formats it should be present modes, like so. That should get rid of the error, and then also instead of formats here should be present modes, like so. So make sure that you've made the necessary changes if you also just copy pasted like I did, and that's it, I guess, right? Yeah, that's it. So then so let's extend is okay. We don't need to do that because we've already done all that stuff in the previous videos. So choosing the right settings for the swap chain. So swap chain surface format. So we need to define some static functions. In this case, choose swap chain format, choose swap chain surface format. Wait, what? Choose swap surface format. Oh, it's the same thing. And then choose swap present mode. And I think there was another one. Choose swap extend. Yeah. So those are the three static functions we're gonna implement. So yeah. Okay. So where do I want to do this? I guess I'll do this at the top here. So first one is swap chain surface format. So I'm just gonna yank this. Right? Yeah, I'm just gonna yank this one and paste it over here. Then I'm gonna make this static. And then let's think about how we want to basically implement this function. So let's see. We basically go through the list of formats, and then we basically choose the format that we want. Okay. And then once we found the format that we want, we return the available format. I guess, am I reading that correctly? Yeah, right, we just return the format that we want. Okay, it's a fairly simple function. It's fairly small if you look at it, so let's just copy this entirety of it, actually paste it here, and then let's just do static like this. Okay, so we just need to get rid of the C++ stuff. So the way I'm gonna do this one is I'm gonna rename this to just formats. Instead of that, we remove that, and then we remove this, remove the, and then we just make this a pointer. I guess I can get rid of the const. However, we guess we can leave it there, but I'll just get rid of it. It's fine. And then for, we don't have this for loop in C, so I might have to modify this to a normal for int equals to 0 loop. So let's do that. Let's do int I equals to 0, where I is less than. I'm gonna make use of my own array function here, so which will just give me the count of formats we have in that list. So we just pass in the formats list, and that is coming from here. So we pass that in there, and then we increment I. So I plus plus, and that should be our for loop right there. And then of course we need to modify this to suit our implementation. So let's see what they're doing. So they're saying if the format is equals to this. So I guess I can just say, instead of available format, ours is just formats at the current index dot format. Okay, if the format is equals to this, and which is a bg8, right? It's a bg8, g8, bg8, g8, r8, a8, srgb. Do I want to settle for that? I guess I can for now, I guess, and if I need to change it, I'll change it in future. So then what I'm gonna do is gonna take this again and just paste it here, and just forgot the F, so instead of format it should be color space, and then if the color space is equals to the sRGB nonlinear, then it's fine. So VK color space sRGB nonlinear KHR. I guess I'll settle for that as well. And then if it matches, so if the current format matches the format that we want and the current color space matches the current color space that we want, then this is the surface that we want to return, right? So what we're gonna then do is just say return that format at that current index, and that should just do that for us, right? Otherwise we need to return a default format. In this case, they just pick in the first format in the index, so I'll just do the same, keep things simple, and that's the function right there. Okay, modified to suit our needs. So it's pretty simple, right? Yeah, so what's next? Next is the choose swap present mode function. So I guess we can also just yank the entirety of this function and then modify it to suit our needs. So sometimes plagiarism is totally fine, guys. You don't need to reinvent the wheel, right? So yeah, so let's do static, and then choose, in fact I might need to rename these names because they're not what I like to use. So swap, guess I can do swap chain. I don't like the fact they're just saying swap. And then we can say surface format. So choose swap chain surface format. I think that's much better and more readable. And then we can do choose swap chain present mode, like so, right? And then here, instead of this, I guess we can just get rid of all of this, and then instead of available present mode, we just do present modes. Okay, and we'll pass through the array that contains all the present modes we currently support, and we'll just have to fix this. So I'm gonna copy what I did here, and just paste it in there, and then instead of formats it needs to be present modes, so paste that in there. What is this crying about? Oh, extra brackets. And then I guess we can do present modes at the current index I. Does this have anything? No, I guess this is how you do it, right? And then it says mailbox. Do we want mailbox? Okay, so if it matches the mailbox, then this is the one we want to return. But I don't think I want to use mailbox though. Otherwise it should return VK present mode 5.0. And that's the one that I want to return. Oh, that's the one I actually want to check for. If you're curious what are these, just go to the implementation and you'll find a variety of them. So you have immediate, mailbox, first in, first out, first in, first out, relaxed, shared demand, shared continuous. Yeah, but remember that not all machines actually support all of these, so you need to query to see which your machine support. So I know on Mac, to check what Mac actually supports, just basically search for your terminal, open your terminal, do Vulkan info, and you want to search for present mode KHR, I think. So let's just search for that. Nope, nothing. So let's just search for VK present mode 5.0. Wait, hold on for a minute. Copy, oh, and then paste this here. Again, no. Wait a minute, present modes. So yeah, just type present modes, I guess, and you'll notice the count is 2 because on Mac we only support 2 modes. That is the first in, first out, and the immediate. Now if you don't know what these do, just do this, just copy this and go down to the internet and just say p present modes. Hopefully, well, let's do Vulkan present modes. Hopefully what I'm looking for will be in here, and then you'll see what it says, right? It will tell you what each one does. So VK present mode, first in, first out, and this is what it does, right? So you guys can just read, right, what y'all want. In this case, I want this one, and luckily for me it's at index 0. So what I can do in my code here is I can just say I want this. I want to check if that is supported, and if it is, then return that one. Okay, but if it does not exist, still return that one. All right, because that's the one I want, and that's the one that we want to support. Okay. Another way you could have done this is just take this and put it out like this and just say 0, and it'll just return the first one it finds. And the first one it finds, indeed, it will be the 50, so it will be at index 0 anyway. So you could do it that way, or you can just be totally explicit about it, and I think I might just go with this one in this sense. Okay. I just realized I'm brute forcing it to give me this, which is probably not a good idea, but I'll just leave it like this. But anyway, it's fine. I know it's supported on Mac, so I guess I'm safe by just rudimentarily, explicitly setting it like that. Yeah. So what's next? What's next is we need to choose the swap extent. So where is the implementation? I'm just gonna copy the whole function here and paste it in here, and then let's just make this static, like so. And then of course we'll just need to modify this to suit what we need to do. Man. Again, we have some weird C++ syntactic sugar that I hate. I mean, what is this? Like, tell me, what is that? Why does it have to be so cryptic? Like, what? You know what? I'm not even going to entertain that. I'm going to clean this up and just make it use C. So yeah. Let's see, how do you want to fix all of this? They're comparing this with a max UI in 32. They're comparing the width. So current extent. We're returning this actual extent. I guess we can start with this. So I'm going to remove this. I'm going to put this up here because this is what we're going to return. So the actual extent. Let me think about this real quick. Const vk servers add capabilities. This should just be a pointer. This is the list of capabilities we have. I think. Well, it's not even a list actually. Yeah, it's not a list. I'm thinking. Actually, you know what? Get rid of this. Let's rename this. Let's do an out extend. This is the extent we're gonna be returning. And then I'm going to do out extend. I'm going to do width equals to capabilities dot current extent dot width, right? I'm going to set it this way. I'm going to do a height here, then here height. I think I like it like this. Then max. How I'm gonna change this though? Oh boy. So yeah, so we want to get rid of this. But how? How do I simplify this? Is there a way I can find? Oh yeah, actually there is. So max UI 32 max. I guess we can do it like this. Then capabilities, this should just be a pointer, and that should be fine, right? Then they're returning the current extent. Guess we can do it like this, right? Yeah, I guess. Return current extent. But if that's not the case, then we say width height glfw frame buffer size. glfw frame buffer size. Well, we don't use glfw, so how am I gonna deal with that? Yeah, how am I gonna deal with that? Damn, that sucks. Actually, I feel like this does actually return the actual size of the screen of our window, so we don't need this. And the fact that I'm actually doing this outside means that I actually do not even need all of that, right? Okay, so what we'll then do is the actual extent is the one we're returning, isn't it? So this could just be out extend. Then we have std clamp, which we don't have in C. I'm gonna have to do my own clamp function. I think I already have this in one of the renderers that I made, so I guess this is probably in the defines.h. Yeah, we have quite a lot of stuff in here, so I guess we can just copy the clamp part, and then also just go down to the defines.h and just paste it somewhere down here, clamp, and then I think it should work out the box. Don't know. Let's see. Clamp. Why is it with lowercase? Is it in lowercase though? Hold on. Clamp. Yeah, actually I just want this in cap. So let's do clamp. Yeah, I think this is better. So back here, that should just work. And then let's see, what do we need to do? We take in the actual width, and then we're basically going to, hold on, let me look at this. We take in A, X, and B. So X less than A, return A. Then if X is greater than B, X greater than B. Okay. Alright, let's see. This will be the out extent. So that will be the actual width that we want to clamp, and I want to clamp it between these two. So this is a pointer, and this is a pointer. So I think that should be fine. Yeah. Alright, cool. So then we're gonna do this, and I'm just gonna copy this, and this should just be the height, and this should also be for the height, and I think that's fine, right? And then the actual extent that we're returning is this. Oops, is the out extent. Okay, I guess we might have to do some testing on this function. I'm not quite convinced that this actually works for us, but yeah, I don't know. But yeah, we'll see, right, when we get to test this. So once we have that, we finally have to create the swap chain itself. So we do have the function for that, right, which is right here. So we basically have to call the query swap chain first, right, because we need to query for everything. And then after querying for everything, we then need to, let's see what they did. They query for everything, then they basically take the format and the modes and the extent that they need. So I'm gonna copy this, paste it here, and then just rename these things. So surface format, present mode, and the extent, and then this should just be choose swapchain surface format, Swapchain surface format, and this should just be choose Swapchain present mode, and then this should just be choose Swapchain. What was it? Extent. Where is it? Where did I define that? Oh, here. So I need to rename this actually. Choose Swapchain extent. Yeah. And I just want to organize this. I'm going to put this right after the query. No, wait. Yeah. Oh, no, it is actually in the right place. Yeah. So present modes. Next, we just need to copy the name and then just replace it here. And then Swapchain support formats. That is in context. So I can just say context.swapchain.details.formats, and I can do context/swapchain.details.present modes with a lowercase, and then I can do context/swapchain.details.capabilities. Oh yeah, this is not an array, and boom, that's how we do it. Right? Sweet. So now what do we need to do? We need to get the image count. Okay, let's get the image count. Let's copy this. Okay, get the image count. So that will be a U32, but we can just reduce to like this. So U32 Swapchain support, that is context, swapchain.details.capabilities.min image count +1, and they explain to you why it's like that, so you guys can just read that. I'm not gonna go over that. And then we have an if statement here, which I think I'll also just yank. Paste this here, and what is this doing? We should also make sure not to exceed the maximum number of images while doing this, where 0 is a special value. That means that there is no maximum. Okay. Okay, so context swapchain dot details dot capabilities, context swapchain dot details dot capabilities, and then the image count is the context swapchain dot details dot capabilities dot max count. Okay, so that's what they're doing. Then what's next? S is tradition. Oh, so then we need to do the swapchain create info KHR. And I think I'm gonna be lazy here as well and just copy paste this in here. Save this, and I guess we can take all of this here as well. Mac, what are you doing? Okay. And because this is C, this is how we do this. And then the surface will be context surface, image count. I actually want to rename this image count. Yes, I'm very picky with my namings, so do forgive me for that. Surface format. Is this the surface format from here? I presume. So let's put that there, and then surface format like so. Yeah. All right. Yeah. And then the extent, I guess, is this one. And then present mode is still not used. I wonder where that goes. Okay, but then we set this to 1. Image usage, color bit. Again, I just copied these, but you guys can read as to why they're doing it that way. But I've already read through this like I don't know how many times now, so I'm not gonna do that. And then what do we need? So Q indices. Ooh, this is where it gets interesting. All right, so I'm gonna copy this, paste this right below that, and I might have to change a few things. So let's see what exactly is actually happening here. Right, so we have Q family indices, right? And then find key family indices. We don't have this, so get rid of that. And then we have key family indices, graphics family, present family. Okay, so on Mac, I mean, we just created one key family, so the index is 0, so I don't need to get the indices for those. It's just on the same queue family, so that will be 0 by default. And then the other thing is, in fact, let me put a comment so that you guys understand why I did it this way, or I'm doing it this way. macOS, graphics, and present, queue families share the same index. Okay, so that's my justification for that. Okay, so what is this if statement? So if graphics family is not equals to indice present family, then we do this. However, on Mac, that will be true, right? This statement will be false because they do share, right? And they will always share. So I guess this check is useless for us. Yeah, that check is useless for us because they will always share, right? And the count, I believe it will just be 1. Or queue family index count should be 1, right? Let me think about this. Queue family index count. Let's see. We have sharing mode concurrent and sharing mode exclusive, but I don't think we need both of these. We need to choose. What was that if statement? If they don't share, then we do this, but if they do share, we do this. So it means this is for when they don't share, so we can get rid of that because we know they do share. So then all we left with is this one, right? Because we're on Mac. Oh, okay, that was easy. Yeah, that was really easy. And then you guys can just read what exclusive and concurrent means. So yeah. And then from there we can move on, and I think we now need to do the pre-transform, composite alpha, present mode, and all of this. So I'm gonna copy again. I'm gonna paste this here because I think we might just use the defaults, right? I guess I'll just have to read it properly first before I make my complete judgment on that. So paste this here. All right, and then this should be context swapchain dot details dot capabilities current transform, and then the composite alpha opaque. Actually, I think I'll leave it like that. And then the present mode. Oh, this is where this guy finally gets used. So I'm gonna move him here. And then clipped. What was clipped again? Present mode, clipped, member set to VK true. That means that we don't care about the color of pixels that are obscured. For example, both because another window is in front of them. Pixels. Okay, I guess I'll leave that true. Then old subchain. What was that? This leaves one old subchain with Vulkan. It's possible that your subchain becomes invalid or unoptimized while the application is running. For example, because the window was resized. In that case, the subchain actually needs to be recreated from scratch, and a reference to the old one must be specified in this field. Ooh, this is a complex topic that we'll learn more about in the future. For now, we'll assume that we'll only ever create one subchain. Which is also the case for us right now, so we'll leave it as a vk null handle. And then now we need to add the class member vk swapchain katra object. Where do I want to add this? Well, let's copy it first. and I think I know just the place for that. So let's go to our Vulkan defines. Let's go to the swapchain, and let's put it in the swapchain. And I just want to move this to the top. Swapchain. I guess we can say swapchain.handle. Okay, and that will be the swapchain handle. And back into the swapchain.c. I think all we then need to do is just call vk create swapchain. So I'm gonna copy this function. I'm gonna paste it in here. In fact, actually I shouldn't have copied it, but it's fine because I like to separate my stuff. So let's do vk result equals to this, and then we're gonna check if the result is not equals to vk success, and if it's not, we basically throw an error message. So in this case, error, failed to create the Vulkan swapchain. And then here it wants the device, so the device is the logical device in this context. So let's do context / logical device. Then it wants the create info. Again, I'm going to rename this personal preference. So this changes to this, and all of this changes to this, and we just you know what, let's just do this like so. And then null pointer, replace that with 0. Let me just check what that was. Oh, the allocator, we don't have one, so that is 0. And then it wants finally the swapchain, which is the swapchain handle which is created, and that is in the context swapchain.handle, like so. Okay, makes sense? Hopefully that makes sense. And then after creating the swapchain, all we need to do is destroy the swapchain. Oh, okay. Okay. So I guess I can just copy this, and then just paste it in here. vk Vulkan destroy swapchain. The device is the logical device, so we can do context logical device, and the swapchain is the swapchain we want to destroy, and that's in context swapchain.handle. Yeah, and then the null pointer, I presume that's the p allocator, which we don't have. So we can save all of this, and that's beautiful. And before I forget, I don't think we're calling this destroy function in our Vulkan renderer. So we create the surface, and then after creating the surface, before destroying the surface, we need to destroy the swapchain. Then we're just gonna pass in the context, and I think that's it really. And then back into the swapchain creation, we've now, well, this gets called when it failed. So we probably want to return false here because we're returning a boolean. So return false because it failed. And then that's it, right? So let's see if indeed that is it. Retrieving the swapchain images. Ooh, we actually need to retrieve the swapchain images as well, and the swapchain image format and the swapchain extent. Where do I want to put this? I guess we can just put it in a swapchain struct, right? I guess, right? Yeah. Okay, so let's do, yeah, let's just swapchain format. Yeah, let's do this one first. Okay. Where do I want to do that? Here. Actually, these belong in the struct, so copy that. Go to our defines.h, and I think I'll put that in here, right? Because we already have the swapchain as the handle. Next, we need to store the format, so this will be the swapchain image format. So I don't have to, I can get rid of the swapchain name because we're gonna say swapchain dot, so image format. so that's fine. Then we're gonna do swapchain dot swapchain extend, so we can just say extend. Okay. And then we have the swapchain images. Swapchain dot images. I guess that will be also cool, right? This will be the array. So let's do vk image. Make this a pointer, and I'll just say array. Okay. So that you guys know that's an array of images. I think once we have that, we are fine. So then the only thing I should be doing is caching, because I guess this is what we're doing, right? Which is caching. I'm just gonna copy this. Swapchain image format, swapchain extent. For us, this is context swapchain dot image format, right? Then here is the same situation, right? It's going to be context swapchain dot extent. That should be the extent. I think this is this guy, so do it like that, right? And that's us basically just caching the surface format, because this is what we're doing here, right? Cache the surface format and extend for later usage, or for later use, I guess. And then retrieving the swapchain images. So we already have this as images, so all we need to do is just query. So we can just query and paste this here. Device is the logical device, the swapchain, and the well, that's quite a mouthful, so let's just do this step by step. We need the logical device, the swapchain, which is the context swapchain.handle, the image count. I presume they're using the image count that is above, right? Where is it? This one. Okay, presume that's what they're using. And then null pointer, image count, vk image. Okay, so this should be 0. Okay, then swapchain images resize to image count, so this should be our array. So this will be context swapchain dot images, right? We should just create the array. So array, and we want to reserve, so let's do of type vk image. It is vk image, right? Yeah, of type vk image, and we want to basically allocate space to be equals to the image count, like so, I guess. Yeah, and then once we have this, we can just copy pretty much this, and this should be the logical device, the swapchain handle, the image count. So replace that with that, and then the swapchain images array, which is this. So that should do it. And I think, given that, we are sort of done. But before that, again, let's just make sure that our array does indeed have the exact number of elements in there. So swapchain images, like so, then set the count to the image count, like that, and that's it. Right? And then we can just do like a ldebug, be like Vulkan Swapchain created successfully, right? And then we can basically do this, and then here I can just maybe say get the swap chain images, I guess, or you can just say retrieving. I guess that's a better description, right? So retrieving the swap chain images, and that should just store them in our images array. Yeah, I think that's it. So let me save this. Yeah, saved. So let's build, see if we have any errors. We don't. How lovely. So let's clear and let's run the app. Let's see. Nothing crashes, nothing breaks. So let's see what happened. So Vulkan Swapchain created successfully. And you also notice that it said created 3 swapchain images with the size of 1200 by 960 and content scale of 2.0, meaning that it's actually reading the layer from our window because the content scale was indeed set to 2. And then on screen built-in retina, it's also detecting that we are on a retina display. So hence this, because this 1200 and 960, that is due to the fact that our window size, let me just show you real quick, our window size is 600, right? So 600 times 2 gives us 1200, right, which is what you have over here. And then 480 times 2, what do you have? So 4 plus 4 is 800, 80 plus 80 is 160, so that's what you have here, right? 80 plus 80 is 160, yeah. So this is what you have here, 960, right? So that will be 800 plus 160, which is 960. So that is just multiplied. This is multiplied by 2. This is multiplied by 2 because we're converting it to pixels, or to match the retina display pixel ratio, I guess, right? Hopefully that makes sense. So that's it, ladies and gentlemen. We have our swapchain created, we have our swapchain images, and yeah, let's move on to the next section. And what is the next section? Do I have it? Yes, we have image views. So, well, image views, didn't we just do that though? Hold on. Swapchain image. Oh no, this is images. It's not image views. Okay, so that's a totally separate thing. And just to confirm it is, let me see something. Yeah, it's totally different. Okay, so this is what we're going to be doing in the next video, so definitely stay tuned for that. If you guys enjoyed this video, I know it's been a long one, definitely hit the like and subscribe button, as it helps grow the channel, and I'll see you guys on the next one. Cheers.